Welcome to this explainer. Let's jump right in because I am absolutely thrilled to be your guide today. I want you to imagine for just a second that you're starting completely from scratch today, right now in 2026, and you want to learn machine learning. Where in the world do you even begin? Well, as a senior applied scientist who's been deploying production ML systems for the past 7 years at Twitch and someone who's personally coached over 200 people into the field, I'm going to reveal the pragmatic, no-nonsense 2026 roadmap. And I'll tell you right off the bat, it looks very, very different from what you might expect. If I had to start over from zero today, I would do almost nothing the way I did the first time. Look, if you've been grinding away and just feeling completely frustrated, your struggles are so valid. Honestly, a huge chunk of the machine learning career advice floating around out there right now is from people teaching the exact path that got them hired way back in 2019. But this industry has evolved at lightning speed, and that old path, it simply is not going to work today. Okay, let's dive into this step-by-step, chronological roadmap that will take you from day one all the way to a job offer. We're going to cover 1. Intuition over heavy math. 2. Mastering Python and fundamentals. 3. Building projects from scratch. 4. The Gen AI era. And 5. Networking and interview prep. Part 1. Intuition over heavy math. So the first major roadblock beginners face is this total massive misconception that you absolutely need a PhD-level grasp of calculus before you can do any useful ML work. The old way, which is unfortunately how I learned, involves spending painful, exhausting months reading dense math books cover to cover and deriving the chain rule by hand. And sure, yeah, it worked eventually, but it took years longer than it needed to. And frankly, I was still just guessing why my models failed in production. The new way for 2026 is all about visual intuition. You really want to use resources like 3Blue1Brown or StatQuest to visually understand matrix transformations or what geometric derivatives actually look like in practice. What this brilliantly illustrates is that the actual math required to start is way, way less than people claim online. You just need enough linear algebra to know what happens when you multiply matrices together. You need enough probability and stats so things like Bayes' theorem and basic distributions aren't terrifying, and you need enough calculus to understand the chain rules so backpropagation makes sense. That's pretty much the whole shebang. Everything else, you just learn it on demand when a specific problem actually calls for it. My absolute most vital advice for this stage is this. Spend just 2 to 4 weeks building this rough mental map. Please do not fall into the trap of spending months and months watching educational videos, feeling like you're making incredible progress, when in reality, you haven't actually built a single thing yet. Move fast and build that intuition. Moving right along to part 2, Master Python and Fundamentals. Once the math actually feels approachable, we need to grab the foundational tech skills. You need a solid high-level overview. What exactly is the difference between classification and regression? What do tree-based models like random forests do compared to linear models or just basic neural networks? Resources like Andrew Ng's courses are absolutely perfect for this. But to actually apply any of it, you need Python. Python is the default language for machine learning, no question. Gaining a rough mental picture of these core concepts and getting comfortable with Python libraries like NumPy and Pandas really sets the stage for the absolute most important learning trick in this entire explainer. Let me just ask you this directly. How do you truly understand an algorithm? Think about it, because most beginners do the exact same thing. They open up the scikit-learn library, they call .fit on a model, they get a decent result back, and they falsely assume they actually know what just happened under the hood. So the crucial point is, if you want to truly understand what's going on, you have to implement it from scratch. First, understand the basic math. Second, code it out entirely from scratch using only NumPy. And third, literally watch the data flow through each mathematical step. Implementing algorithms like logistic regression, k-means, or decision trees entirely from scratch takes the magic out of it, and it just turns it into pure, understandable logic. Plus, this secret trick doubles as direct interview prep. Hiring managers will absolutely ask you to code these out from scratch in an interview. Which brings us to part 3, build projects from scratch. All right, we need to have a painful reality check here. People who study all the theory, take all the courses, do everything quote-unquote right, they still fail the resume screen. I've seen this happen over and over again. Someone's GitHub is just full of course exercises and Kaggle notebooks. But look, in those environments, the problem, the clean data, the evaluation metrics, they're all handed to you on a silver platter. Hiring managers learn almost nothing about whether you can do the actual job from a Kaggle notebook. They need to see that you can operate in a professional environment. And that means identifying a unique problem, finding messy data, evaluating it systematically, and actually deploying it.
You have to build real solutions. Small scopes are totally completely fine as long as every choice is yours. Maybe you build a churn prediction model for a friend's small online shop using real transaction data. Or maybe you're super into fitness, so you build a meal planning app that factors in grocery costs. The goal is to end up with a project you can actually demo to real users who will absolutely tell you when it breaks.
And to really make those projects shine, you need the 2026 Hiring Tech Stack. A basic Jupyter notebook is just a starting point nowadays. To actually move the needle, your project needs to be containerized with Docker and deployed on the cloud using AWS or GCP. You need basic CI/CD pipelines, and you should definitely be tracking your experiments with tools like MLflow or weights and biases. This stack tells a hiring manager you aren't just a student anymore. You are a professional who is ready to ship code.
Part 4. The Gen AI Era.
If I were giving this advice, even 6 months ago, I would have focused purely on classical ML. But while classical ML still deeply, deeply matters for foundational knowledge and interpretability in fields like finance or healthcare, the entire industry is hurtling toward AI engineering. Here are the modern Gen AI requirements you absolutely must know for 2026. First up, RAG, Retrieval Augmented Generation. It's not just about knowing how to build it, it's knowing exactly when to use RAG versus fine-tuning a model. Next, evals. Building evaluation pipelines is now a massive chunk of a machine learning engineer's job, and frankly, most people have zero idea how to do it. You also really need to understand agents and how they use external tools. And finally, prompt security. You have to know how to defend a production system against prompt injection attacks. Now, as you learn all of this, you will obviously be using AI coding assistants like Cursor or ChatGPT. But I need to give you a very stern warning about a trap psychologists call the fluency illusion. This is when an AI hands you a perfect, flawlessly written answer, and you walk away feeling like you totally understand it. But you didn't actually do the cognitive work. You avoided the friction that actually makes knowledge stick in your brain. Use AI to explain concepts, use it to quiz yourself, but never, ever let it outsource your thinking.
And finally, Part 5. Networking and Interview Prep.
I wish I could tell you that those standard leak code data structure rounds are completely dead. They aren't. Big tech companies still use them for sure. But while your portfolio and your coding skills get you past the technical bar, there is a second, much bigger differentiator that decides if you even get the interview in the first place: who you know. Networking is literally the single highest leverage thing you can do to get a referral and land a job. And the great news is, you don't need to be born with elite connections. Go to industry conferences, be highly active in online communities, reach out to experts you admire with genuinely thoughtful questions about their work. Build your network purposefully. Do not just rely on luck. We have covered a massive amount of ground today. The path in 2026 is faster, it's far more practical, but there is still a ton of ground to cover in a constantly changing market. It's not going to be easy, but I promise you it is absolutely worth it once you make it into the field. So armed with this modern roadmap, the intuition, the production skills, and a real understanding of the Gen AI era, are you ready to build? Thank you so much for joining me for this explainer. I truly hope this roadmap empowers you to take that next big step in your machine learning journey.